Hi everyone. Today in this video we are going to clarify sway frame and non-sway frame structures. As you know, there are two types of frames. One is determinant frame structures and another one is indeterminate frame structures. But most of the frame we use are indeterminate frames. For indeterminate structures, we can use vertical and horizontal force equilibrium and moment equations to analyze structures directly. But in indeterminate structures, we can't use them directly. So that we use displacement methods to analyze frames. Here are some displacement methods to analyze the frames, especially for indeterminate structures. As you know, for frame analysis, we use displacement method such as slope deflection method, moment distribution method, and stiffness method. Stiffness method is finite element method. Now, we are going to see what is sway. So, what is sway? Now, consider a structure A, B, C, D. Two fixed end supports at A and D. Okay. Now, we are assigned a force in lateral direction. Lateral directions means a force in horizontal direction at B. Element BC deflects laterally. So, total structure sways. If structure had any strains at C, to resist the lateral deflection, it can't sway. But this instance, we don't have any resistance to resist this lateral deflection in this frame. Now, let's see what is sway. Sway is lateral deflection of joint B and C. As we know, delta B, it means deflections in this joint area. Deflection in this joint B is equal to deflection in this joint C. It means delta B is equal to delta C. Why? Because BC is a rigid bar or rigid element of this frame. Okay. Now we are going to see what are the checking criteria for sway. Symmetry of column of frame. At both sides of symmetrical axis, both columns has to be identical in all characters. In this structure, symmetrical axis is here. At both sides of symmetrical axis, both of the columns means AB and CD have to be identical. Identical means they have to be same in cross section A, second moment I, elastic modulus E, and etc. Length and heights also can be considered as a physical characters. They has to be also identical. If both of the columns are identical, then this structure is non-sway structure. Another criteria is symmetry of loading. Around symmetrical axis, both sides loading it has to be same in magnitude and direction, and position also it's x. For an examples, 10 kilonewtons x in B and also in C. Then it's a symmetrical loading. If the loading is symmetrical, then the structure is sway structure. Sometimes if we have distributed load, uniform distributed load over B to C, it is also a non-sway structure because it is symmetrical at both sides. Okay. Let's we check another criteria for sway. Symmetry of support of column. Here at A and D, we have fixed end support. It can resist all the three translation force and all the three moments. So it's non-sway structure. If we have pin joints at A and D, it's also non-sway structures because at both sides of symmetrical axis, they are identicals in support. But if we have fixed end at A and pin joint at D, then it violates. It means they sways. Finally, we can say if all these three conditions are positive, then it would be a non-sway structures. What are the three conditions? Symmetry of column of frame should be satisfied. Columns must be identical as we see before. Symmetry of loading. Loading must be symmetrical at both sides of column. At symmetrical axis. Symmetry of support of column. The support of columns has to be identical at both sides of symmetrical axis. Okay. Well, we understood what is sway structures and non-sway structures. Then here's an important note, very important note. Here is that important note. Although a structure violated all the three conditions to be non-sway structure above we saw, it can be converted as non-sway structure by adding reaction in horizontal direction. It means lateral reaction. For examples, this frame is non-sway structure. How? Because even though it's violated our three criteria we saw before, I can say this is non-sway structure. Let's see why. It violates of criteria. Columns are not symmetrical. Its height varies. Yes, as we said before, we have a restraint here. It resists the lateral direction, so there will be no lateral deflection here. How much you push here, it can't deflect in the another side. So it is non-sway structure. Let's add a mark here, and it is very important point to analysis because this is a significant point in non-sway frames and sway frame analysis. Okay, here are some simple and very interesting and also very easy questions just to identify whether these structures are sway structures or non-sway structures. Okay, let's see our first structure. Let's think it's sway or non-sway structures. You can simply say it's non-sway structures because it satisfies all the three criteria we see before. It has identical columns and identical supports at both sides of symmetrical axis here, and loading also symmetric here. At the second illustrations, we can say it is sway. It sways because our criteria here, it's violate the first criteria about this columns, and it's also violate the second criteria about loadings. It is non-symmetrical about the characters of columns here and also characters of loadings here. Third one is also sway structures, because here is a symmetrical axis, here we have fixed joint, and here we have pin joint. So it's violated the supports criteria for sway structures. And here loading is symmetrical at both sides of symmetrical axis, but the supports violates, so it is sways. It is sway structures. Here symmetrical axis is here, the supports of columns violates our criteria, but I can say this is non-sway structures. Why? There is a violated criteria here, even though it can't sway, so it is a non-sway structure. Why it can't sway? Even though when we are giving a lateral force here, it can resist using this pin joint resistance here. So it is a non-sway structures according to the note we saw last. Okay. Thank you for joining with us.